Okay. Excuse me. I'll do my best not to be ill. Well, might as well share my video as well. My name's Neil Chandler. Working with Oracle for a very long time makes me feel very old these days. I'm a member of the UK Oracle User Group, a board member there, and I'm an Oracle ACE director. All the Oracle ACE program means is that we're a group of technologists who really enjoy sharing with the community. It doesn't actually mean we're experts, it means we enjoy sharing. Generally speaking, Oracle ACEs are experts, but it doesn't necessarily mean that that's the case. As always, take everything I say with a pinch of salt, test it yourself, and make sure you're happy with anything before you look to implement it in your systems. Okay, so top 7 plan stability pitfalls and how to avoid them. Let's hope my demos work on this. It's been a while. So this is my favorite slide. I use it in many presentations. And it's basically the optimizer. What's the optimizer do? The optimizer takes a parsed representation of your SQL statement. And it uses statistics to generate out multiple plans. It finds the plan with the lowest cost and then it executes it. It's basically just a calculator. It's just taking known inputs, working out the best way that it thinks of to get to your data with the lowest cost, the lowest amount of effort. Now, it could spend all day trying to work out the best way to get to your data. But that would take time, making sure it's absolutely exact. So the optimizer has currently 2,000 guesses at getting the correct access path. The problem with that is that a 5-table join could have up to 30 million possible access paths. Now that might seem like a ridiculously high number for a 5-table join. But what you've got to do is look at the join order. And that's the order that the tables are going to be joined in. Are we going to join table A to table B, to table C, to table D, to table E? Or are we going to join table A to B to C to E to D, or A to B to E to C to D? And all of those, when you multiply them together, is 5 factorial for a 5-table join. And that gives you about 120 possible, exactly 120 possible permutations, 5 factorial. So if we take that and we work out how we're actually going to join each one together. Now Oracle has 3 join methods. It can do nested loop, hash joins, and merge joins. So between each join order, there is a join method. And so that gives you 3 times 3 times 3 times 3 for the 4 joins of the 5 tables. That's 81 multiplied by the 120 we got earlier. So we've now got 10,000 join orders and join methods. And then if we add on to that, the different ways that we're actually going to potentially access the data in the table, we've got in this list, full table scan, index unique scan, index range scan, index skip scan, index fast full scan, a bitmap conversion, a star schema transformation, a Bloom filter, a bitmap indexed single value, a bitmap index, range scan. But ignoring the ones on the right, we've really got 5. Most tables in most systems will work on the first 5. So that's 5 times 5 times 5 times 5 times 5 potential ways to access the data in each table. That's 3,000-ish. Multiply that by the roughly 10,000 we got earlier. That's 30 million possible access paths. And Oracle's only got 2,000 guesses. To give you an idea, this expands exponentially. For 6 table joins, it's 2.7 billion potential access paths. So the optimizer always gets it wrong for complex SQL. Well, that's a bit too much, but it's always a guess. And sometimes the optimizer changes its mind and we don't notice. This actually happens quite a lot. We get different plans, we don't notice anything has changed because they're kind of similar. But sometimes we do notice. Sometimes we notice a lot. So the question is, why did Oracle change its execution plan? What caused it to make a different decision? How can I make the optimizer make the right decision? And I suppose, what am I really looking for from the optimizer? So a common cause of new SQL execution plans is you added some data to your database, you gathered statistics on at least one of the objects that you're accessing, your plan aged out of the shared pool or was invalidated, and Oracle re-optimized and came to a different conclusion based upon how to access your data because of the new statistics. Or maybe you did nothing. You didn't add any data. You didn't change your statistics. You kept running exactly the same query every day, day after day, and then your plan changed. I'll hopefully be able to do this via a demo. Right, okay. So I've got a small table here. Just ID column, date column, text columns. And I've put 1,000 rows of data in the table. We've got statistics on it. But the only thing that's changed on the stats gather is I've done for all column size 1 to keep histograms away so things don't get overly complex. And that's the statistics on it. 1,000 rows, 1,000 row sample size. And if I do a select from this table, and the select I'm doing is selecting a text column where the date column is today, and we get a table access full, it pulls in all 1,000 rows. So now I'm going to put a bit more data into the table. I've just added 30,000 rows. We've now got 31,000 rows. I haven't changed my stats. The optimizer still thinks there's 1,000 rows in there. So if I run that query again, with all that new data in place, flushing the shared pool first, we still get a table access full. It still thinks there's 1,000 rows. It still thinks I'm getting all of the rows. However, compared to the last time I gave this presentation and now, this has appeared. Dynamic statistics used.
Neil, can I just quickly kick in? Where we have requests that you can please change the font size or the resolution because people have trouble reading it.
Right, okay, let's see what I can do. Sorry. Let's see how this goes. Is that a little better?
We have to ask the audience. Can you guys please tell us whether it's okay now? Okay, it seems to be better now. Thank you, Neil.
Not better. Okay, thanks. Cheers, Chris. Right. Oh, didn't want that up on the screen. So we've got this new line, dynamic statistics use statistics for conventional DML. And what does that mean? And the reason this is here is because this is running on an Exadata. It's an Exadata simulation, and it's running Oracle 19.5. So Exadata features on. Oh, this is messy. I wonder if I can make this a little narrower. This is really impossible to read at this. Let me just see if I can make that a little. Hopefully people will still be able to read this. But what we can see here is in user tab called statistics, hopefully you can read it. For each column, we now have two sets of statistics. For the date column here at the top, we've got our normal statistics, where it's telling me I have a high value of December 25th, low value of December 25th. And we've got these statistics here where we've got some notes which say stats on conventional DML. What's going on here is a thing called real-time statistics, which is available on Exadata and for Oracle in the cloud, not for normal Oracle, normal Enterprise Edition on premises. But what Oracle is doing is, as you're doing DML, it's sampling the data going through and changing your statistics or adding to your statistics, or at least the simple ones, as your queries, as your data is changing. So we added 30,000 rows. If we look here, we can see the sample size here is 311. It's sampling at a roughly 1% rate. And it's only updating some of the simple stats. It's not updating things like density, because that's a difficult calculation to do. It can't do that on the fly. What it is doing, though, is capturing low value and high value. And so we can see the low value is changed from December to November as we put in some earlier data. Now, if we gather statistics again, all of these stats on conventional DML will vanish. It reads much better this way. And our stats on conventional DML have vanished, and we're just left with the normal stats for the date column because the stats have been updated. If we run the SQL again to see if the plan has changed, we can see that we've gone from a table scan to an index range scan. Our plan has changed because we added data, we gathered stats, it got a better plan. What is interesting, though, is that even with the real-time statistics, Oracle did not manage to spot the better plan. So the real-time statistics are of limited value, largely because the density didn't change. Okay, so we can see we added data, we gathered stats, plans change. That's expected, that's normal behavior. But what if the stats and data don't change? Well, I've got a table here. It's exactly the same table, nice, simple, small. It's got 3,000 rows of data in it based upon the 24th, 25th, and 26th of December. Now, if I do a select for today, which is the 25th of December, we know that because I set a fixed date earlier. So we're on the 25th of December. If I do a select for the 25th of December, where the date column is trunk sys date, I get a full table scan. That's what we'd expect. It's grabbing a third of the data, 1,000 rows, with a cost of 13. If I do a select for tomorrow, 26th, so I change the fixed date to the 26th, table access full, 1,000 rows of data, cost of 13. That's what we would expect. Flush a shared pool, change it to the 27th, and our plan has changed. The SQL is exactly the same. However, Oracle thinks it's only going to retrieve 500 rows, and the cost has changed from 13 to 11. So what's going on there? But what if we look at the day after that? We changed to the 28th of December. We've changed plan. It thinks it's only going to get 1 row with a cost of 2. So why has that happened? Nothing else has changed. Well, what Oracle is doing is it's looking at the low value and high value in your statistics. And it's changing the cardinality, or the amount of rows it thinks it's going to get back based upon that. And this is something that we call statistical decay. Just like to explain it slightly further. So if we've got a date here, it's got 15 days worth of data, 1st to the 15th of April. If we do a query where the date is the 13th of April inside the range, the query cost may be, for example, 150 to make the maths easy to understand on this. But if we query outside of the 1st to the 15th of April window, Oracle thinks there's a low cardinality, less rows will be returned because it's outside of the high-low value that you've given me. And so therefore the cost will be low because it's doing less work. So over the course of the next 15 days, you get a linear reduction in cardinality and therefore cost. So if we query where the date is the 20th of April, the cost drops to 100. For the 25th, it's down to 50. And for the 30th, it gets down to 1 because Oracle thinks it's incredibly unlikely that you have any data in there. And the same is true of the other end. So this is statistical DECAY, or the high-low value threat. What is interesting is with, if you've got real-time statistics because you're on Exadata or in the cloud on Oracle 19 and onwards, this becomes less of a problem because as you tend to add data to the end, it will generally be spotted by the real-time statistics and that particular stat will be kept up to date. So this is vanishing as a threat for cloud and Exadata, but not for ordinary enterprise edition. Okay, so from those two examples we have learned your execution plans can change when you add data, they can change when you gather stats, they can change when you don't add data, and it can change when you don't gather stats. So let's try no stats. If you don't have stats in the database, Oracle uses a thing called dynamic sampling, where it goes and reads some random blocks in your heap and looks at the data in them. It uses the data from those blocks to say, well, this is representative of the data in your entire table. And dynamic sampling has a number of levels. You switch it to 0, it's switched off. If you set it to 2, that is the default. So if you've got one or more tables that have no statistics in them, or you're using parallel query, but that's beyond what I'm going to talk about today, it will go and sample 64 blocks of data by default, yeah? So it's going to go read 64 blocks and say, the contents of those blocks are representative of all of your data, which may or may not be true. If you set dynamic sampling to level 4, if you have conjunctive, which is ands and ors, or complex expressions, column plus column equals something, where the optimizer can't easily determine the cardinality, it will go and do sampling even if you have stats, and will do 64 blocks. From Optimizer level 5 to level 9, it does the same as level 4, but progressively doubles the amount of blocks it's reading each time to try and make it more accurate. So obviously you're going to get a better set of information if you're reading 4,000 blocks. And if you set dynamic sampling to 10, it will sample every block in the database. Effectively, it'll do a full table scan as part of some dynamic sampling as part of your parse to get the best plan that it can, which may or may not be a good idea depending upon what you're trying to do, but I would imagine OLTP, very bad idea. In Oracle 12, we were allowed to turn this up to 11 when the optimizer will look at the stats that you have and say, well, actually, I think I should be doing dynamic sampling here because the stats are not good enough. And so you can get dynamic sampling at even more different points. And I don't have a demo for dynamic sampling because it's all a little bit random. And so it's hard to produce a consistent demo that I can show where we get the same results every time because it's dynamic. Dynamic sampling is not a good idea for OLTP applications. So, cardinality feedback, which came around in Oracle 11. Oracle uses cardinality feedback when you have no stats after it's done some dynamic stats gathering. It will do cardinality feedback where you've got complex predicates and where Oracle can't calculate the cardinality very easily, and where you've got ors and ands. And what it's doing is it's comparing the estimated row counts, or the estimated cardinality from your statistics to the actual row counts, the actual amount of data that has come back whilst the SQL is executing. And you can see in read-all-as SQL shared costs use feedback stats, whether it's going to be intending to use that. So what happens, and Chris was talking about this earlier, your first parse gets a plan, but it gets marked as having poor cardinality. Your second run, you get a hard parse again, a child cursor, and we get plan B and we stick with plan B. Yep. Our plans may then age out of the shared pool. And so you go back around to plan A because this is only held, this information, cardinality feedback is only held in memory. It's in your shared pool. Things get kicked out of the shared pool. And so when your shared pool gets refreshed, you may have to go back around this loop again, getting a plan A, a bad plan, and then coming back around to getting plan B, getting plan changes. Now in 12, they reneged cardinality feedback to statistics feedback, which is a bit more literal. And the use case for stats feedback is exactly the same as cardinality feedback. And we get this v.equal is reoptimizable, yes, which will cause a hard parse of the cursor and the production of a child cursor. We also make it a thing called a SQL plan directive. This is the default in 12.1, but can be switched on in later editions. And what a SQL plan directive does is it kind of semi-permanently stores the fact that you've got a stats problem. And interestingly, SQL plan directives are not associated with individual SQLs, but with columns and column groups. So they can be used more widely than just the individual SQL, where it's detected a potential cardinality problem. You may also get some extended statistics created where you have column correlations, or Oracle thinks you have column correlations. Now, SQL plan directives only have two types of directives so far. They've got dynamic sampling and dynamic sampling result from 12.2. Any stats that get stored in the dynamic sampling result will age out the same as your ordinary stats get aged out, when by default you have a 10% change and they go stale, and the dynamic sampling result gets resampled at that point. Now, adaptive statistics are not good for stability. But the other thing that came in 12.1, adaptive execution plans, is good. And unfortunately in Oracle 12.1, they're both controlled by a single parameter, Optimiser adaptive features. So if you want to switch off adaptive statistics in 12.1, you can't switch it off without also switching off adaptive execution plans. So in 12.1, if you're using an OLTP system, it's a good idea to actually just go and disable the SQL plan directives. Don't just drop them. If you drop them, they get recreated pretty quickly. So they get, it's spotted that they're missing. It's also a good idea if you disable them to set them to auto drop. Sorry, I'll say that again. To set them to not auto drop, because after 53 weeks unused, a SQL plan directive is dropped and got rid of. And then, of course, because it's no longer there, the optimizer will pull it back in. But this was a real particular problem in Oracle 12.1. In 12.2, Oracle realized that they hadn't put enough control in for us, because most people wanted the optimizer adaptive plans, but did not want optimizer adaptive statistics. So by default in 12.2, it comes shaped like that. Adaptive plans are switched on and adaptive statistics are switched off by default. And one thing that Chris did speak about was bind variable peaking. And I'm going to kind of cover similar ground here, but from a slightly different angle. As Chris said, bind variable peaking highlights a contradictory element within the optimizer. Execution plans get stored in the shared pool, and we use bind variable substitution so we can reuse more execution plans in the shared pool and avoid the parsing overhead. But where we have non-uniform data, and most data is non-uniform, we may want different plans for different input variables. So I've got a wee demo that's similar, but not the same as Chris's, to try that. So, bind variable peaking, revisited. Excuse me. So what I've done is I've populated the previous table that we were using. In the text column, I've put two different values. We have an FTS plan value, which has got 20,000 rows, and an index plan value, which has a single row. So I think we can see in this column does have an index on it. So obviously, if we query by the FTS plan, we're going to want a full table scan. And if we query by index plan, we're going to want an index scan. So I got some stats, and I'm also deliberately putting a histogram on, a frequency histogram on. So this is perfectly described to the optimizer. So you can see that the data is very skewed. So we've got our 20,001 rows, and our text column does have a frequency histogram on it. It's the index on the text column. Cool. And so if I run a quick set the bind variable to full table scan plan, and then I select from the table where it's that bind variable, we get a full table scan. It's what we would have expected. I appear to have a baseline on here that I'm not expecting to have. So just give me a moment. Cool. Okay. Where were we? Let's come back to that. So, ignoring the baseline, because we had an index plan on, it did a full table scan, because the first time we did a query, the bind variable peaked FTS plan, we can see here the peaked bind variable is FTS plan. The index plan wouldn't cause it to do a table access full. If we flush the plan out of the shared pool and do the index plan first, do an index plan, we got our index range scan. There's the peaked bind. If we then run it with the full table scan plan, we still get the index plan because that was the first one in. So you can see where that would be a problem. So from 11G, Oracle starts using adaptive cursor sharing. So we flush the shared pool, we run the SQL for the full table scan. We run that, and we can see the full table scan here, and we can see that it knows it's bind sensitive, but it thinks that it's shareable. So Oracle believes that this cursor is shareable and that it's good for any input bind. So if we run this now for index plan, we still get the same cursor. It's done it for the scan plan. And it's still marked as shareable. If we run it again though, Oracle has identified that it's a problem, and we get a different plan, and we can see here that it is bind sensitive. It's fully bind aware now, and this second plan has been marked as is shareable. The first plan has been marked as is not shareable anymore, which means that this can only be used for the specific input bind variable that we had the first time round. So the full table scan plan. I hope that makes sense. I hope you followed that. Right. Bind variable peaking. So from that, adaptive cursor sharing is useful to combat bind variable peaking issues, but it's not perfect. You've got to hit a bad plan before you will hit a good plan, before Oracle will reparse. it is possible Oracle may never deem your SQL to be shareable, the cursor to be shareable, and you start getting lots and lots of child cursors. And as Chris was saying, you may be better off using literals in those circumstances. It's not always the right choice to use bind variables. It may reduce parsing, but you end up getting worse plans sometimes. So it's something that you do need to think about carefully. You need to make a judgment call as to when binds are appropriate and when literals are appropriate. In OLTP, mostly binds, sometimes literals. Histograms. Oracle loves histograms. They're used to describe the data better within any individual column, and they allow improved cardinality predictions. And the better Oracle gets the cardinality, the more likely it is to get an accurate cost and a better execution plan. Now, frequency type histograms appear on all columns which are used in predicates with less than 254 distinct values. This is from 12 onwards, and with default gathering in terms of your estimate, but you will get frequency type histograms on all columns used in predicates with low numbers of distinct values. And on any columns which have got data skew with more than 254 distinct values, you'll get a hybrid histogram. And Oracle is very, very into doing histograms to try and describe your data as well as possible. The only problem with histograms is that histograms use a thing called adaptive sampling to randomly read usually 5,500 not null rows of data to build a histogram. And that's true for all histograms pre-12 and for hybrid and height balanced histograms from 12C onwards. The problem with that is if you've got a table with many billions of rows in, if you've got a table with 1 billion rows, it's going to use 5,500 rows to say this is typical of your data. And your data is described using a 5,500 row random sample. Now, sometimes that will be representative of your data, and sometimes it won't. But every time you gather statistics against that table, the shape and size of your histogram will change. And sometimes that will be good, and sometimes that will be bad. You also might find you get histograms appearing a bit at random. If you query a column for the first time, that might result in a new histogram appearing. And so it might even just be a DBA querying a particular column a couple of times just to check something out. You might suddenly start getting histograms on that, which can cause stats gathering problems if you're using partitioning. And actually, I would say if you're using partitioning, it's very important to try and control your histogram production explicitly. It's less important in non-partition tables, but if you've got large partition tables, controlling your histogram can control your stats gathers better and your plans a lot better. But you need to be very, very careful with especially height balance and hybrid histograms because they are adaptively sampled. I control, you should always be controlling your statistical gathering using set table prefs. So in this case, I'm saying we don't want any histograms other than on columns 1, 2, and 3. Cool. Adaptive query optimization, we touched on that slightly earlier. Adaptive plans and adaptive statistics. It's a bit of an old graphic that. So, what else can make your plans change? Well, from Oracle 12, Oracle can change your plan whilst your code is executing. So during SQL execution, the statistics collector is analyzing the blocks that are being read in and comparing them to the estimated number of rows that have come out of your table stats to actually what's happening. And Oracle's making some decisions about whether it got its plan right. And depending upon the amount of data being returned, it may decide to change a number of options. So it can change a join method from a nested loop to a hash join or back. It can switch a parallel query distribution from broadcast to hash or back. And the reason it will do both of those, the nested loop to hash join switch, is if it's getting 10 times more or 10 times less data than it was expecting. Of course, the more data you're putting through a query, the more likely it is for it to be using a hash join, because hash joins are more efficient with large amounts of data. Likewise, it will want to do a parallel query broadcast when you've got less than 2 times the degree of parallel in terms of the amount of rows that you're broadcasting. You do a hash distribution when you've got more than 2 times the degree of parallel. It can also, on star schema transformations, eliminate bitmap indexes if the query associated with the bitmap index is not eliminating enough rows from your query. It's going through, it goes, well, okay, this just isn't getting rid of enough rows. It takes a lot of power to scan through an entire bitmap index. It's not efficient enough, and it just eliminates it from the query. And when you're looking at your explain plans, you can tell which bits of the plan are being switched off by adding the format plus adaptive. And it will actually show you what is going on with where it originally thought the plan was going to be and what the plan is now. And there's a v$SQL.isResolved adaptive plan to tell you whether it actually did any adapting of the execution whilst it was going. And I've got a quick demo to show that. I'm doing this, this is just going to be a join demo. I've created 2 tables. Each table has a very uniform set of data, but one table, I've skewed the data then on two of the columns. For where its value 1,000, the data is very skewed, and where the value is 200, the data is very skewed. So it's going to get the plan wrong and then adapt it, hopefully. So what is worth looking at the moment, but just here, is the difference between doing an explain plan 4, between doing auto trace, and between using DBMS Xplan. If we do an explain plan 4 on this join, and all we're doing is joining table 1 to table 2 on the 2 skewed columns, it's giving us a plan saying, oh, this is what I think is going to happen. We've got 25 rows. We're going to do some nested loops. There's statistics collector. We're going to do table access full, and so some index work over here. And as you'll see in a moment, this is really quite wrong. That's just what Oracle thinks is going to happen. If we do set auto trace, trace only explain, we can see that this plan isn't quite the same as this plan. I don't see any hash joins in this plan. It still thinks it's getting 25 rows. But one thing that we can see here is this is an adaptive plan. Now, it's not showing any adaptations. It's also still wrong. It's not what it's going to be adapted to. But it's better than an explain plan 4. But it's still not correct. So the only way from Oracle 12 onwards to guarantee you're getting an accurate representation of the execution plan is to use DBMS Xplan. So if I run this for real and do DBMS Xplan.display cursor, we get this. Now what we can see is this is an adaptive plan. Rows marked with a hyphen or a minus are inactive. And what that means is it did a hash join. It never did this nested loop. This nested loop never happened. This nested loop never happened. And it pretends the statistics collector never happened, but this is what was doing the work to adapt the plan. And then table access full, that did happen. And then we've got index unique scan and index and table access by index row ID. They never happened either. So all these 5 rows never actually happened. If we look in v$SQL plan statistics all, it tells us the amount of rows that actually went on. And if we look at that in our plan here, we can see it was estimating it was going to get 25 rows for this row in the execution plan. It actually got 2,500. And that's what caused, and all of these cardinality misestimates is what caused the plan to adapt from a nested loop to a hash join. If I run this query again, we should see statistics feedback kicking in. And instead of using an adaptive plan, the cursor has changed because the adaptive plan was marked as is reoptimizable. The cursor has changed, and we now have a hash join, table access full, table access full. If we were to wait 15 minutes or so and run it again, we might get a SQL plan directive appear. But I'm going to go out of my way to actually force a SQL plan directive to appear so we can actually see one. So if I'm just going to run this again a couple of times and get the optimizer to create a couple of SQL plan directives, the intention being, and we can see when we've run it a couple of times, to force this, I ran this flush SQL plan directive in the middle of the runs to create the SQL plan directives explicitly. And what we can see is that the SQL plan directives, 2 of them were used for this statement, but it was still an adaptive plan to start with. If we look at the SQL plan directives, what did we get? Well, we can see we have 1, 2, 3, 4 SQL plan directives here. We've got the dynamic sampling result. So that's basically statistics, and the dynamic sampling directive, which created the dynamic sampling result. And exactly the same thing. So for test table 2 and for test table 3, we have the same sort of SQL plan directives, forcing dynamic sampling. Fortunately, not every time it executes the way it did in 12.1, but forcing dynamic sampling and using that result for those columns on those tables by saying that your statistics are not good enough. More reasons your plan's changed. Some other reasons. This was, I think I said 7, didn't I? Other reasons that your plan's changed is you might have changed some initialization parameters, like your memory pool sizes. That can cause many different plan changes by changing things like small table thresholds. Or Oracle might have helpfully changed the plans for you with automatic memory management, if any of you are using that. You may think no one uses that. I know some very big sites who are still using AMM. You might have modified some optimizer specific parameters. You might have dropped, added, or changed an index. And you might have plan changes, even if you're not using an index. So you've monitored your index, you've ensured that nothing is using that index. The index is never ever called and used. And so you drop it, and suddenly your plans change. And your plans change because Oracle might not have been using the index, but it might have been using the cardinality calculations associated with the index. Or sometimes if you, well, generally one of the biggest problems is when you upgrade. If you patch, PSUs, CPUs, and RURs don't change the optimizer, so it shouldn't change any plans. However, BPs and RUs will fix wrong results bugs and will put optimizer changes in upon occasion, but you need to explicitly enable the change. And that's only happened once that I can think of in the last few years. Oracle are very resistant to putting optimizer changes in patch releases. So that was a whole bunch of changes for the optimizer. So what do we want to do about it? Well, the CBO is complex. It's getting even more complex, and more layers are added onto it all of the time. So what do we do about our plans changing? Well, Oracle have got 4 mechanisms to kind of cope with this. Stored outlines, SQL patches, SQL profiles, and SQL baselines. And stored outlines were the first attempt really to control this. You can associate them with SQL statements. They're basically a whole load of hints. They may even be desupported by 19, certainly deprecated. And it's just trying to control the access path. So unlike when you put hints in as a developer, you'll tend to put 1 or 2 or 3 hints in. Stored outlines use a lot of hints. And they work pretty well, but they're pretty inflexible. The biggest problem with stored outlines is once you put them in, they stick. No one ever wants to remove them. So you discover you go to a customer site, or you look in the database that was put in 1998, and there are stored outlines in there from when Oracle 8 first went in. And people are scared to remove them, even though you're now on Oracle 18 rather than Oracle 8. If we quickly look at a stored outline, for a very simple SQL statement, a very simple join here, just emp and depth join, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 hints for a very simple SQL statement. I think someone asked Chris, should we use hints? Hints are fine, but people generally don't use enough of them to control their plans as fully as they think they are. Hinting to the fullest degree is very difficult. If we tell database to use stored outline, and now we can see just in the notes, stored outline was used for this statement. The second way, and this is actually not a bad way to put hints into your code, because it's much more enableable and disableable at the database level, if those are words, is to use a SQL patch. This was DBMS SQL diag_internal.I create patch, and what I'm doing is I'm putting the hint full into this select statement. And what happens by running this piece of code, we do select star becomes select /star plus full star. This actually drops hints in directly. It's what a SQL patch does. And importantly, it doesn't require the tuning license. It works on standard edition. And from 12.2, it's no longer in DBMS SQL diag_internal. From 12.2, they've moved it to an officially documented function in DBMS SQL diag.create_SQL patch. If you're putting hints into an SQL, this can be quite a good way of doing it. Because then rather than having to go and revisit and change your code and re-release that, you can put the hint in and take it out quite easily by enabling and disabling the SQL patch. We've also got SQL profiles, which are just a bunch of hints attached to a SQL plan, with an extra one called Optestimate, the intent of which is to change the cardinality of the join predicate of correlation. But SQL profiles are basically, because of Optestimate, static statistics. And you should retune them regularly to ensure that your scaling factors changed by Optestimate haven't gone wrong. They go stale. I've seen SQL profiles go stale after 2-3 months repeatedly. As your data changes, the profile needs to keep up to date, and there isn't a mechanism in the database to do that. You also need a SQL tuning license for SQL profiles. Where they do win is if you're using a lot of SQL literals and are trying to do force matching. And they can also be useful for catching a failing baseline. Because from 11, we've been able to create baselines within Oracle. And the basic premise is that DBA can restrict a SQL statement to 1 or more plans that we say is good. And if a better plan comes along, it may be captured by the database, but it won't be used unless we say that's fine. And Oracle have provided a facility called an evolve, which tells the database to go check out the baseline, test it fully, and evolve it if it's better so it can become allowed, so we get allowed to use that one for the SQL. Let's see if I can show that on demo 5. Right. I'm going back to my full table scan index plan. And I'm going to gather some stats, as we did before. We're going to run for the full table scan, as we did before. And now let's capture us a baseline. I want to capture this so with this SQL only ever does full table scans. So set the capture on, run the SQL, set the capture off. So this is a cheap and cheerful way to capture baselines. Optimize capture SQL baseline true. Run the SQL more than once, set it to false, all is good. If we look in DBA SQL baselines, we can see the baseline there. It is enabled and it has been accepted. Flush the shared pool, do a hard parse. We get a full table scan for our query with the FTS plan. However, if we flush it and do a hard parse for the index scan, we still get the table scan because the baseline is forcing it to use the table access full. However, if we look in the baselines, we see a new baseline has appeared. It's not accepted, it is not allowed to be used, but Oracle has seen that there's a potential for a better plan and captured that potential. But we've locked it out of the way. We've made everything really, really tight and locked in place. Now, we can use DBMS plan to display SQL baselines to show the two different plans. There's table access full, there's an index range scan version, but this one is again not accepted. But we can run an evolve to say, go and see whether you should accept this. So we're doing it, and scroll off. We're doing an evolve report. So set to a club exec DBMS SQL.evolve SQL plan baseline. It's coming in, it's comparing the base, which was the one that we have, with the one that we're testing. And it actually goes and it runs a number of executions and compares what happens. And it has captured the bind variables that we used. So it's testing it with the bind variables we supplied. And we can see here, it thinks the new plan is 82 times more efficient. So therefore, that's plan, and because we didn't tell it not to, that plan has now been accepted. And it's showing me what the plan is here. So I can now go and say, run the index plan. We can see the index plan and the baseline has been allows that plan to use. If we go and have a look at it, we've now got two accepted plans. Both of these plans are valid. No other plan is valid for this SQL. I hope you followed that. So, baselines. I captured it using a generic set the capture SQL plan baselines. And what we can also do is capture it in many different ways. You can capture a baseline from the current cursor. You can capture it from AWR, from a SQL tuning set. You can migrate a stored outline into a baseline. That's fabulous. If you've got any old stored outlines, you need to turn them into baselines. And you can copy baselines from system to system to system, which is incredibly useful. But it must be borne in mind there are no free lunches. Baselines do have a parse overhead, and that has got an impact. Oh, Q&A window. Baselines come up with mainly parse overhead, and that's got an impact, yeah? You've got parse heavy systems as a parse overhead because it does a parse without a baseline to see if there's a potentially better plan out there. Then it does a parse with the baseline hints to reproduce your plan. It may then do another parse if the baseline hints fail, do a reparse it, which will get you a viable plan. So sometimes you might have a non-trivial parse overhead using baselines. So if you've got a parse heavy system, that is worth considering. And if a baseline fails, it fails in its entirety. None of its hints get applied. And that can make actually, it can make it very, very difficult to determine what's going on or why it failed. You can tell the optimizer to use the baseline regardless of it actually working or not. If you set SQL Plan Management Control to 4, it allows an undocumented pretend match, and the pretend match allows you to use hint usage reporting in Oracle 19, which will actually tell you why certain hints were ignored, unused, or incorrect. If you want more information about that, you'll have to ask the Optimiser PM, because that's all I know about it. But it's basically a way to get baselines to work properly. It can be worthwhile if you're really worried about an SQL to put a profile underneath the baseline if you have the right licenses. Okay, DBA spent hours, days, and weeks restricting bad plans to ensure you have a neat and tidy set of baselines. But at night, the tuning advisor auto task runs and evolves them automatically. And you've got to ask yourself, is that what you want? Do you want Oracle evolving something you've spent a while locking in place? Because by default, that's what's going to happen. So you might want to consider disabling the auto evolve. It's up to you, it depends how you're running your system. But if I've spent a while putting a baseline in place, I don't want Oracle changing it. And by default, it'll change overnight potentially. So execution plans are important. Consistency is good for OLTP. Adaptive stats can be good for more analytic type databases. Baselining is useful, but you should keep on top of it. Monitor for new plans. Think about whether you really want it to auto-evolve. And keep evolving the plans to make sure you're taking advantage of your changing data. Your data changes, your data distributions change. The numbers change. The optimizer needs to have the best information possible to try and get you the best plans possible. Okay, questions? Cool. So we've got 5 questions. First one is statement from David Kurtz explaining that adaptive a backports 12.2 adaptive optimizer parameters to 12.1. You also need a fixed control. That's worth bearing in mind. I did put when you get the slides, you'll be able to go and have a look and get the appropriate MOS article number. Dropping an index and marking invisible has the same effect for execution plans. I would always recommend marking an index invisible before you drop it. That way it continues to be maintained. The index itself will not be considered for the optimizer. I genuinely have no idea whether it continues to use the stats or not. I suspect it does, but I genuinely have no idea. Does query cost depend upon memory parameters? I don't think so. Chris or Frank may be able to answer that one better than me. I genuinely don't know. I can't think of one off the top of my head. I mean, memory parameters can certainly affect it because it'll decide, you know, things like small table thresholds. It will, you know, the size of your PGA will determine things like whether you use, sometimes whether you use a hash join or a nested loop, because the bigger the PGA, the bigger the hash area that you can use and that sort of thing. So it has an effect, but I don't think it directly affects the cost. Cost is a factor of I/O and CPU. Mostly I/O. It's basically I/O with a tiny bit of CPU added in. What's your recommendation about SQL profile when we upgrade? My preference, if the customer allows, is to disable them all. Is to take them over, to carry them over, but disable them. And see if in your testing whether the, preferably testing on a full-size QA environment, whether your testing will allow you to have a reasonably performing system. Every time you upgrade, you should really be trying to switch off all of the strange initialization parameters you've set. You should be removing baselines and SQL profiles and patches, because the optimizer will have changed on upgrade. If you put patches in place or baselines, you may not be allowing the optimizer to use some of the cool new features. You know, and you know, when you're on an Oracle 11 system and you're seeing outlines from Oracle 8, you just know there's an awful lot that the SQL is unable to take advantage of now. I recommend using SQL plan baselines as the main option for OLTP. I prefer to use SQL plan baselines to control it. I mean, hints have their place. But I like baselines. I think baselines work very effectively. Obviously, baselines can be seen as a bit of a sticking plaster. Oh, we've had a plan flip, quickly stick a baseline on from the old plan, all is good. You haven't fixed anything, you've put a sticking plaster over it. But I've got no problem with using baselines. Just Don't use them for everything. Try to get to the root cause. What impact can cause null false value on resource manager plan parameter to my plans? Off the top of my head, I don't know. I don't know what null false does in resource manager plans, so I can't answer that, I'm afraid. Sorry. How much of these demos are useful or accessible in ADB? At the moment, none. But I'll have a look and see whether I can run these on one of my ADWs whilst the rest of this is going on, and we'll see what spills out of the other end. How to check if a table's making use of stats or dynamic sampling? Look in the explain plan plus note, it will tell you. So DNS xplan.display AWR or display cursor. Make sure your format has plus note and it explains it in there. And when using SPM, is using fixed equals yes advisable? I generally don't. I can't give you any advice on the top of that right now. Sorry. Oh, failure of a final question. Any more questions, or are we all done?
It sounds like you did a good job and covered all the questions.
Cool. I think I ran slightly over, but never mind. Thank you very much for listening, everyone. It's really cool.